Picture a young Thessalosauros grazing peacefully on prehistoric ferns when suddenly the ground shakes. A shadow engulfs the landscape as something massive lands nearby. Quetzalcoatlus, standing tall as a giraffe with wings spanning roughly 33 to 36 feet. Its keen eyesight locks onto the small dinosaur. This wasn't happening over some ancient coastline, as earlier depictions often imagined, but deep inland across the dry Texas plains. The fossil evidence from the Javelina Formation in Big Bend, Texas, dating to the latest Cretaceous period around 68 to 66 million years ago, reveals where this aerial predator actually ruled both sky and ground with terrifying efficiency. But the story of how we discovered the truth about these giants is far more surprising than anyone expected. Early reconstructions and popular imagery often depicted Quetzalcoatlus as a coastal creature skimming over ancient seas like a prehistoric pelican. Museum displays showed these giants swooping down to snatch fish from ocean waves, their massive beaks perfectly designed for maritime needs. Art books depicted them gliding over tropical coastlines, feeding their young with fresh catches from Cretaceous waters. This coastal narrative became deeply embedded in paleontology textbooks and shaped how generations understood pterosaur behavior. The Javelina Formation in Texas completely overturned this vision. When researchers began excavating this fossil-rich rock layer, they discovered something remarkable. The geological evidence revealed that Quetzalcoatlus lived in fluvial floodplains and abandoned channel lakes some 300 to 400 kilometers inland from late Cretaceous shorelines. These deposits recorded stream channels, floodplains, and small alkaline lakes with vegetation, including fan palms and subtropical trees. The abandoned channel lake facies are associated with Q. lawsony-like remains, while the giant Q. northropi specimens are rarer and found in stream channel facies, suggesting differences in lifestyle and habitat preference. This discovery sparked a fundamental reinterpretation of pterosaur behavior. A 2007 study and the later Witten and Naish review in 2008 argued that skimming was energetically unviable for giant ajdarchids, and that their anatomy and inland depositional contexts better fit terrestrial stalking. The conceptual shift from skimmer to terrestrial stalker revolutionized our understanding of these creatures. Popular coastal imagery may have reinforced earlier interpretations, but rigorous sedimentology, taphonomy, and functional studies overturned that view. These giants inhabited semi-arid grasslands with alkaline lakes, seasonal floodplains, and palm-dominated vegetation. Isotopic analysis showed mean temperatures ranging from 16 to 30 degrees Celsius, creating a warm subtropical climate perfect for terrestrial hunting rather than oceanic fishing. The bone-rich Amaral Quarry produced a conservative minimum number of individuals estimate of 15 for Q. lawsony in a single concentration, suggesting evidence for gregarious behavior or repeated use of a lake margin. Multiple specimens found together raised fundamental questions about pterosaur social organization and seasonal patterns. Quetzalcoatlus was perfectly adapted for terrestrial hunting, more like a giant stork than a seabird stalking prehistoric plains with methodical precision. But how exactly did such a massive creature function as an effective predator on land? Standing face to face with Quetzalcoatlus would reveal an anatomy so bizarre, it seems almost alien. The creature's extraordinary proportions defied every expectation of what a flying animal should look like. The head and neck together formed a large portion of the animal's length with skull material from Q. lawsony, revealing a long, pointed, toothless beak perfectly designed for precision strikes. Meanwhile, its legs extended upward like a giraffe's, elevating the creature to heights that allowed it to peer across vast prehistoric landscapes with commanding authority. This presented a biomechanical puzzle that stumped researchers for decades. How could such an awkward-looking giant function as an efficient predator? The answer lay in understanding that every seemingly strange feature served a specific hunting purpose. The neck vertebrae up to 3 meters in total neck length for Q, Northrop I contained internal bracing that strengthened a long, stiff neck suited to stabbing and scanning. This anatomical advantage allowed the giant to scan vast areas for potential meals without moving its body or alerting prey to its presence. Mass estimates have varied, but a majority of recent estimates place giant Ajdarchids around 200 to 250 kilograms, roughly 440 to 550 pounds, while older or contested estimates range much lower or much higher. On land, Quetzalcoatlus moved with a unique quadrupedal gait that coordinated its massive wings with its powerful hind limbs. The forelimbs were long and the folded wing tips reached the ground. When walking, these pterosaurs lifted a forelimb before stepping the corresponding hind limb in an alternating sequence lift. Left forelimb, step left hind limb, step forelimb down, then repeat on the right side. These seemingly clumsy adaptations actually created one of prehistory's most formidable hunters. With elevated head and long beak, they could scan and pluck small prey like modern storks and herons. The long neck provided striking range, the elevated stance offered superior vision, and the precise beak delivered killing blows with surgical accuracy. Small dinosaurs, amphibians, and other ground-dwelling creatures had little chance once Quetzalcoatlus locked onto them as targets. Yet understanding how this massive predator hunted on land only raised an even more perplexing question about the incredible engineering that somehow kept such an enormous creature airborne. The flight capabilities of these giants remain one of paleontology's most debated topics. Because mass estimates vary widely, some older scenarios posed extreme challenges for powered flight. Recent biomechanical work, however, supports a viable launch strategy that could have kept these massive pterosaurs airborne. Early theories proposed that Quetzalcoatlus used running takeoffs similar to modern albatrosses or condors. Researchers calculated the sprint speeds required for such massive wings to generate sufficient lift, but the numbers created problems. Body mass estimates vary widely and strongly affect flight models. Many modern studies place giant Ajdarchids around 200 to 250 kilograms, but some analyses proposed much higher numbers that would make flight unlikely or impossible. Biomechanical and aerodynamic analyses by Habib and Witten in 2010 and others conclude that powered launch plus thermal soaring was plausible for these creatures. The revolutionary four-limb launch theory transformed our understanding of pterosaur flight mechanics. Instead of running, Quetzalcoatlus planted its enormous wings on the ground like vaulting poles using powerful hind legs plus strong forelimbs as thrust points. Padian and colleagues provided detailed reconstruction in 2021, supporting powerful flight muscles and a leg-powered launch able to hop approximately 2.4 meters to clear the wings. The explosive spring motion began with muscular hind limbs driving a powerful leap skyward. Quetzalcoatlus crouched low, then released stored energy in its leg muscles while simultaneously pushing against the ground with planted wings. This coordinated jump created a short burst of powered flapping followed by thermal soaring. Pterosaur bones were extremely thin-walled and highly pneumatic, with internal bracing and trabeculae making light but strong frameworks. Bone walls measured only a few millimeters thick in giant species, yet maintained incredible strength through structural supports that distributed stress loads efficiently. Pycnofibers covering the body provided insulation consistent with high metabolic demand and sustained flight capability. Some models suggest cruising speeds up to 130 kilometers per hour and very long-range soaring, while others argue for more limited occasional flights. There remains active debate with some recent work from 2022 arguing for limited flightability. However, Padian's comprehensive anatomical support presents the latest evidence for a powerful flyer that mastered both sky and land. Yet even these magnificent aerial capabilities could not protect Quetzalcoatlus from the dangers that awaited every time it descended to hunt. Terrestrial hunting brought Quetzalcoatlus into direct contact with some of prehistory's most dangerous predators. While Quetzalcoatlus shared the late Cretaceous of North America with large theropods, including massive carnivores in the Javelina fauna and Tyrannosaurus in northern regions, direct fossil evidence of predation on Quetzalcoatlus remains absent. However, the ecological logic makes such encounters plausible. Aerial animals become vulnerable when grounded, especially around large terrestrial predators capable of delivering fatal attacks. The vulnerability paradox defined life for these aerial giants. Despite commanding the skies with unmatched grace and power, Quetzalcoatlus became surprisingly exposed when grounded for feeding or hunting. Their massive wings transformed from assets into liabilities on solid ground, restricting movement and creating awkward gaits. A creature capable of soaring vast distances could face serious threats from ground predators in mere seconds. Research suggests that ajdarchids like Quetzalcoatlus likely stalked and captured small vertebrates on land, including small dinosaurs, lizards, mammals, and amphibians, following hunting patterns similar to modern storks and herons, as described by Witten and Naish in 2008. They probably took fish opportunistically and scavenged when possible. However, these hunting expeditions required constant awareness of nearby threats. Adult ceratopsians could easily impale an unwary pterosaur with their massive horns, while alert herbivore herds created defensive formations that discouraged aerial attacks. Quetzalcoatlus ranked among the largest flyers and functioned as a formidable hunter or scavenger. But on the ground, it remained vulnerable to large theropods and competed with smaller pterosaurs and birds for food resources. This competitive complexity shaped feeding strategies throughout their range. Feeding on carrion became a high-stakes gamble where multiple predators converged on single carcasses, turning peaceful meals into violent confrontations. Constant vigilance became essential while probing muddy sediments for amphibians or investigating potential food sources near water. Sharp eyesight allowed Quetzalcoatlus to detect approaching threats from considerable distances, while quick reflexes provided split-second escape opportunities when danger materialized. These behavioral adaptations balanced hunting success against predation risk, creating survival strategies that defined pterosaur ecology for millions of years. Yet even these remarkable adaptations could not prepare them for what was coming. The asteroid impact that ended the Cretaceous would claim Quetzalcoatlus, along with the non-avian dinosaurs, but their legacy transformed our understanding of prehistoric life. These remarkable creatures achieved something extraordinary through three key adaptations. First, fossil evidence from the Javelina Formation revealed them as inland terrestrial stalkers rather than coastal fish hunters. Second, their anatomy tells an incredible biomechanical story. Pneumatic bones, extended next quadrupedal gaits, and the leg-powered launch hypothesis explain how such massive animals mastered flight. Third, despite their aerial prowess, they remain vulnerable to ground predators during terrestrial hunting. Each new fossil study continues to refine our picture of these ancient giants, revealing details that reshape scientific understanding. Given the ongoing debate over Quetzalcoatlus flight capabilities, what do you think? Were they long-distance sky travelers or limited to short, occasional flights? Share your thoughts below. And if you enjoyed this deep dive into prehistoric mysteries, hit that like button and subscribe for more scientific discoveries. The Javelina evidence recasts these creatures as terrestrial stalkers. Their specialized anatomy enabled massive aerial predators, yet ground vulnerability defined their daily survival challenges.